likely than not, then there's this possibility that you could either exonerate a drug company, or you could prove that they are responsible with some reasonable probability, and that by combining experimental data with observational data, you get because there are constraints that in other words, because you can predict if a query is identifiable, like probability of y given do x from observational data, that has to equal the do x from the experimental data, and so that places constraints between those two data sets that allows you to leverage them to get answers, to get these bounds that we're talking about, right? And he mentions in the is guilty with probability one ever possible section, right? He says, people tend to disbelieve this possibility for two puzzling aspects of the problem, right? One, that a hypothetical, generally untestable quantity can be ascertained with probability one under certain circumstances, and also that a property of an untested individual can be assigned to probability one based on the data taken from a sample population, right? And so, I think both of those are kind of really interesting in this kind of ongoing debate about what does causal inference give you, that and even more specifically, what does Pearl style causal inference give you that other kinds of causal inference can't, right? And so I think this is really cool from that perspective. And I mentioned earlier, I don't know if you were on at that point, that I created a probability tree, basically a little probabilistic program that reproduces that uses the data to reproduce those calculations. And I haven't quite got it working yet, but you can calculate the probability of necessary causation using that, using what they've described, using those numbers. It also just helped me just kind of clarify the problem, what these, because he has a bunch of kind of magic numbers in there, like P1 and P2 and Q1 and Q2. And by actually writing the program, I understood exactly what they were trying to do. So it might be worth just reviewing what the program looks like, just so it's kind of, because it's more kind of familiar for folks in this call to see things as a probabilistic program than necessarily the way that Judea Pearl presents the problem.
Did you have it in like a Jupyter notebook?
Yeah.
Oh, cool. Well, it's interesting. While you're spinning that up, I'm curious so from Pearl's circle, as it were, I see a lot in terms of bounding of causal queries.
Yeah.
It's a big theme from their work. I'm curious what folks here feel about that. I think that we're in our heart, we're all Bayesians, and we all kind of think when we see bounds being put on things, we're like, well, why don't you just put a prior on it, or some kind of inductive bias, and see if you couldn't narrow that down a little bit, as opposed to just putting tight bounds. Or on the other hand, maybe Eli, who works with stochastic variational inference, all of a sudden is all the time is used to kind of thinking in terms of bounds from an optimization perspective. I don't know. Curious what people think.
Can you Robert, can you give me permission to share my screen?
Oh, sorry. Should be good now.
Okay. All right. So this is the table that they described, and the thing that's missing from this table is the Z term, the syndrome, right? And that's what once you include the syndrome in the data table, then all the mystery is kind of taken out, because you understand what's really going on. And so they have, so your probability of syndrome, this is the probably just getting a prevalence of syndrome in the population. Probability of death given your syndrome is 1. So that's the really kind of the key underlying, obviously these can change, but for this simple problem, it helps to understand what's really going on. And then, if you probability of death given that you take the drug with no syndrome, probability of death given that you don't take the drug given no syndrome. And that's, so there's some kind of risk factor by taking the drug if you don't have the syndrome, right? And then it doesn't matter. And so then your legal liability is that's the whole thing here. So the prevalence of the syndrome is just 1 minus R or R. That's just the prevalence of the syndrome in the population, and then X is a function of Z, and then there's these two parameters: the probability of X1 given Z0 and X1 given Z1, and that's what Q1 and Q2 correspond to. So if you don't have this syndrome, then your probability of taking the drug is Q1, and if you do have this syndrome, then the probability of taking the drug is Q2. And likewise, if your patient, now it's a function of two variables. So there's the possibility if you have the syndrome, then you die. Otherwise, your probability of death is dependent on whether or not you took the drug. So that's the whole function right there. And then here's the probability tree that corresponds to that graph. And you can do things like calculate the probability of doing X1, where I force people to take the drug, and I can calculate the probability of Y1 of death given taking the drug, and you can see that although originally the probability of taking the drug. Wait, what's the word I say? So probably, yeah. So here we go. There's what I'm looking for is X1 here. Yeah. So the probability of dying if you take the drug and you don't have the syndrome is only 0.028. But if I force people to take the drug, then that probably jumps up from 0.028 to 0.041. So, and then I try to get the counterfactual working, but this doesn't look right. So it should be the case. So I say, all right, what I'm trying to calculate is given X1 and Y1, what if X0, right? And then what's the probability of Y in a world where I did not take the drug? What's the probability of survival? And that should be 1, but for some reason I'm getting 0. So that's why I'm not quite ready to play with this yet.
Sorry, I dropped out because of a bad connection. Have we argued about definitions yet? Because that's what
let's talk about definitions.
Yeah.
So the definitions are all here. So if there's any confusion about what the definitions are, we can hopefully sort it out right just by looking at this code. What was the question that you had about the definitions?
I mean, maybe it's resolved just because we're in the binary treatment case, but it seemed really strange to talk about probability of necessity without considering all the other counterfactuals that that we could be considering.
So what other counterfactuals did you want to consider?
Well, I guess, right. So if your treatment is continuous, for example, then to say that an intervention is necessary for an outcome means, as far as I can tell, that you need to enumerate all the other, okay, maybe not continuous. Maybe it's a high dimensional categorical, right? You have to enumerate all of the other assignments of treatment and show that under all of them, the outcome would not have happened.
Yeah, I think there's a paper from Dave Sontag's group that outlined an idea called counterfactual stability.
Mm-hmm.
And I think what it was if I remember correctly, as a generalization of monotonicity, specifically in that paper to the categorical case. And it was basically defined in terms of expectation. In a continuous case, I also wrote a paper where we did it for binomial. in a continuous case, like, I don't know, you could define, so with mediation, which are counterfactual, which using Pearl's notation is a counterfactual, like natural direct effect, natural indirect effect, those are counterfactual ideas. You could write them in terms of derivatives. Maybe you can do the same thing for some kind of general notion of probability of necessity. So X happened and Y happened. Would Y have happened had what's the probability that Y would not have happened had X not have happened? And so, you know, making that yeah, I'm sure you can write it in terms of limits and come up with something, but
yeah. Sam, could you just restate or just clarify exactly what you meant in terms of?
Yeah. When I think of necessity, I think of it as in this context, there is no other way to achieve the outcome other than
No, just the opposite. Just the opposite.
Right.
That would be its presence. So X's presence is required for the outcome, right? But there could be other ways. So if you don't have X, then Y won't occur. That's the thing that you're trying to figure out, right? So the setup is you see X and you see Y. And the question is, if X had not been, would Y still be?
I see. Yeah, okay. That makes sense.
And then you can flip it around. You can say, all right, let's suppose I see X is false and Y is false. And the question is, if X were true, would Y also be true? What's the probability that Y would also be true? So that's sufficiency. You know, it's sufficient for X to be true to make Y true.
So what if X is X has a really high cardinality here?
Okay. So it's not true or false, but it's like,
it's just right. You know, some integer, right?
Sure.
One through n. So you observe that X equals little x, Y equals little y. How do you define probability of necessity now?
I think you have to kind of combine. I think probability of necessary and sufficient causation is defined only on Boolean variables.
Okay.
Because it's a logical operation, right? You can talk about, right? You know.
That's right. You know, it's you know, something happened. So we're talking about events happening or not happening, and so this event happened, or this cause happened and this outcome happened. Would the outcome have happened had the cause not happened?
Yeah. Okay. Okay.
But in terms of, the question about some of the assumptions that we might make, like monotonicity, or what Sontag outlined, that kind of more general, what do you call it, counterfactual stability. It's the idea of, that gets to whether we can identify that counterfactual from observational and or interventional data. And so it's the, so like in a legal setting, probability of necessity is interesting because it's a formal definition of what lawyers call but for causality. But in the kind of in a mathematical setting, we're interested probably in you know, can we define interesting counterfactual queries like probability of necessity, and then what are the properties of the data generating process that would allow us to identify those queries from observational and interventional data. Have I blown your mind, Sam Whitty?
Well, something still feels off about saying this is necessity. right? Like I'm just thinking of, there are settings where you need many events to happen in concert for an outcome to happen.
That's right.
And maybe I'm not.
Well, the term necessity comes from the logical definition. So that's, so like we're talking, just necessity and sufficiency and
Right.
logic. So, I mean, I think it follows from the logical definitions.
Yeah,
Or
okay.
even perhaps a softening of those logical definitions, a probabilistic softening of those logical definitions. So what's the probability that we have a necessary condition?
So, I mean, I hear what you're saying, Sam, is that how does this extend to like more than two cases, right? I think that's maybe your concern. Like, what if you have like lots of symptoms, and you're trying to figure out what the disease is, right?
Right.
And how can you, and there are many possible diseases, right? So you're thinking, oh, the cardinality is really large, right?
Right.
Yeah. Right. And so there's a way of reformulating probably necessary and sufficient causation to handle kind of many diseases and many symptoms. And so I'm just going to put that in the chat window. It's a really neat article by folks at Babylon Health. I think Robert Ness knows those guys. Let's see, where's the chat? There's the chat. So they published this in Nature Communication. What was that?
We should get them on these calls.
Yeah, totally great idea.
Yeah, they're invited. I think
they were there originally.
I was worried about missing work or something.
All right.
Came to a few of the early ones.
That's right.
Right. I think another example I was thinking of is like you have a set of genes, right? And we like to talk about them as like this gene causes your height or something. But my understanding is that's kind of an oversimplification, right? And we have the coordination of many genes that result in phenotypes.
Sure. So, but I mean, this does happen like when I'm looking, and I do like metabolic engineering of microbes, right? And so I'm really interested in what are called essential genes. These are genes that are required for growth, right? You knock them out, cell's going to die, right? And then, so you can like play these games where you're like, all right, well, maybe this gene is not necessary for growth, but I even knock out both of these genes together, then that is called a synthetic lethal, but it's basically just like I need two genes in order to knock it out. Knock out gene one, no change in phenotype. Knock out gene two, no change in phenotype. Knock them out both. All of a sudden, they're both required for growth.
Right.
That's a good use case because you can easily just represent that using sets and stuff like that, and all the Perlian math would be straightforward. Yeah,
and in fact, the reason why you get these synthetic lethals is because there's some branch, there's a parallel branch where they both feed into some, required function. And if you knock out either one, then it's fine. But if you knock them both out, it's a parallel series kind of issue, right?
Mm-hmm. So my read on this work is that we're more or less trying to bring the math to what we colloquially call, causing something, right? And maybe my discomfort is just because, the language, the colloquial usage is too blunt of an instrument to match to these mathematical notions. But in that setting where you have two genes that are, say, redundant, right? If you knock out both, then you lose the trait. But if you knock out either one individually, it's fine.
Mm-hmm.
Would you say that either one of those genes causes the outcome? I mean, my intuition here is that statement, does it cause the outcome, is just kind of a vague and meaningless statement, and that we should be using the kind of descriptions given in papers like this.
So it's certainly sorry, go ahead.
Go ahead, Zenner.
Oh.
Yeah, I think it's certainly true that when you consider a lot of these examples, you find the kind of like an impedance match between natural language and what the math says. And so sometimes I come to the conclusion that you've come to, which is just to say that the words that we use in the natural language are perhaps umbrella terms and they mean multiple things.
Right.
And rather than try to work a lot to align these things. We should just use the precise definitions, the mathematical definitions. I think at the same time, I think there are some clean concepts which we still haven't quite figured out, right? So some of the stuff that you were saying at the start about these kind of, I may have misinterpreted, but a lot of what this paper doesn't talk about is when there are other, other potential causes, right? And you have these problems of preemption and so on. And I think these are real problems, which are not just about kind of the alignment of words to notation, basically.
Yeah, Pearl goes into that a little bit, I guess, in the last chapter of his book, the actual causality chapter. I guess Senna still has some beef with that definition.
Yeah.
So just in response to Sam's question, you're right. When you have two, when you have a synthetic lethal, then neither gene itself is necessary for growth, but you can talk about sufficient causation, right? So if both genes are knocked out and you observe no growth, activating either gene is sufficient for growth, right? So you can talk about the probability that X1 is sufficient for growth and that X2 and the probability that X2 is sufficient for growth. They're both 1 in that case.
So connecting this to law, if I knock out gene 1, and am I responsible for the consequences if someone else knocks out gene 2?
That's a really interesting question as well. So there's a paper where Judea Pearl says, look, we've got a room and both oxygen and a match are both required for a fire, right? But the probabilities are different in terms of like your priors on the likelihood that oxygen is going to be just sucked out of the room versus you light a match. And so because those priors are different, you can distinguish why lighting a match is more the but-for causation, whereas having the oxygen is more about a sufficient causation.
I also think
Joseph Halpern has a bunch of examples in his book along those lines and talking about normality of causes that basically can put in ordering on how unusual a background state of the world is.
Yeah, I also didn't find that convincing. I mean, I kind of feel like there are two kinds of things. One, there's like some kind of primitive notions of causation. And then there's everything else that you need to do things like judgment, responsibility, blame, and to kind of reduce all of that complexity to like a simple, purely causal theory, in my view, is a mistake, right? So when you get to questions of... Sorry?
Sorry, I cut you off. Go ahead.
Yes. Yeah, just so when you get to things like, is somebody responsible for something? I think this brings into all of the complexity of human social relationships, right? That you have to model in complicated ways and are not just purely causal questions.
Right.
Yeah.
I mean,
there are examples in Halpern's book. And let's see, think of one example about like professors taking pens when they're not supposed to. And it's like it's isomorphic to another example, including a normality condition, but it's just like the only difference between them is social intuition that causes people to be more likely to blame the professors for the pens for being out of pens.
Mm-hmm.
Yeah, I mean, maybe another way of answering your question, Sam, is that it seems like we can only ask a question like that with reference to a causal model. And I guess in legal settings for like drug interactions, I guess like a famous example is grapefruit interferes with lots of drugs, the metabolism of lots of drugs. In particular, it increases the effective dose of lots of drugs. So, if you're prescribed certain drugs, your doctor will tell you not to eat grapefruit. And then if you go ahead and eat grapefruit anyway, and you try to sue the drug company,
out the hard way, by the way.
Yeah, you try to sue the drug company, then
do not do that.
you won't, you won't get very far.
I was going to kind of riff off that Zen a little bit, like, well, for one thing I found that's useful when looking into these actual causality issues is to not use ethically loaded examples like, you know, responsibility for murder or, you know, things that are, you know, high stakes, but rather because what happens is that kind of social constructions of ethics inevitably creeps in. But if you keep the examples simple, like, you know, one of those, I mean, I know people are kind of allergic to simple kind of contrived toy examples, but one useful thing they have is, like, you know, say for example, one of those double prevention examples where I go to turn the stereo off, I go to turn off the stereo by pulling out the plug, and you stop me by standing on the plug to prevent me from pulling it out, and then maybe somebody else goes and presses the off button. Like, those examples I find to be a lot less difficult to kind of parse in terms of formal logic. And then they also, you know, there's a whole body of literature from cognitive science that are looking at the relationships between explanations and causality, and, you know, and that's kind of rely on definitions that rely on kind of two agents having a shared model of the world and same context, and you know, wanting to you know, when you explain something, and so for example, if I'm trying to figure out what caused something, the building to cause fire, the arsonist or the presence of oxygen, the explanation would focus on the arsonist because the presence of oxygen is already presumed to be present, and so by both interlocutors. Like, so there's a big body of literature on that, which the Halpern stuff completely ignores. Well, I don't know if ignore might be a strong word, but, you know, they don't. It's not heavily themed, I'd say. Which, you know, is interesting, I think, to this group, since a lot of the technologies we work on were, you know, originally coming from some kind of computational cog sci background or motivation.
Mm-hmm. I think it is worth, like, you know, a lot of what this paper is about, and a lot of what Powell talks about these days, is kind of like shaking his fist at people and saying, hey, you need to take into account causation. And I think, you know, it's obvious to us, but actually it's not that obvious to many people, right? So, you know, I was reading the paper the other day, and it was about causation in cognitive science, right? Kind of what you're talking about, Robert. And, you know, they're defining causation pretty explicitly in terms of, like, just the first half of the expression that Powell has written down. Basically, is something more probable as opposed to like when it, P of y given x minus P of y given x prime, or whatever it is, right? Not taking into account any explicit notion of causation. And it does run into all of the issues that Powell has written about in this paper. So I think part of this paper is just reaching out to those people and saying, hey, you need to explicitly take into account causation in your notions of causation.
Yeah, in particular, I think that as the paper says, that first term is the sort of legal standard.
Right.
It's like the excess risk ratio.
Right.
Yeah, the excess risk ratio is really cool, because you're, like, as you were saying, it's the second term where where it's the difference between the experimental and the observational effect, that it's like, he calls it the adjustment term, right? Or the correction term.
Right.
And that if you only consider the excess risk ratio, then you would get a probably less than 1/2. But if you consider this correction term, then all of a sudden it bumps it way above 1/2, right? So you can just get better legal decisions by incorporating that additional term.
Mm-hmm.
But you're right, the standard is still excess risk ratio, right?
Mm-hmm. One question I had is, in this, like, does anyone have an intuition of this, the upper bound on equation 5?
Yes, actually,
I think it was
this
a typo.
paper doesn't do it, but there's in his chapter 4 of causal inference and statistics, he has some really nice bounds figures that provide that intuition. So remember, the only difference between the lower bound and the upper bound is what he calls Q. Oh, I don't, maybe he didn't do it this way. So yeah, so if this was in the paper, equation 4.30. What was that?
Can we break down figure 2? Because I think that.
Yes, I'm about ready to get there. So
okay, great, thank you.
Yeah. So this is the upper bound and this is the lower bound, right? And
I kind of think the lower bound is a typo.
Maybe. Well, okay, so lower bound is just excess risk ratio plus the correction factor, right? And he talks about that right here. So probably necessity. So this is the excess risk ratio right here, and this is the correction factor, right?
Right. So how did the? Anyway, keep going.
No, I listened to your talk, and I think you might be right that there's definitely at least one typo in the paper. He refers to P2 twice, but he means P1 in one of those cases. But so then the upper bound is the error is the excess risk ratio plus the correction factor plus this Q factor right here, which is just the ratio. I don't know if you can see this is really tiny. Let's see if I can blow it up here. Yeah. So that's just the ratio of the two outcomes given X, right? So why not, y0 given X and y1 given X. And that Q, just go back to that figure here. Or no, you were talking about figure 2 in the paper. We'll get there. But
yeah, okay. Sounds good.
But this is where you break it down. So here's the excess risk ratio. Here is the correction factor, and here's Q. So Q is basically the difference between. So this is probability necessity up here, and this is the upper bound for probability necessity, and that's the lower bound. And Q determines that gap, and it's true for any value of so. And so this Q, this gap here is constant. It's just the size of Q. And I think in this case, the correction factor and I guess this is when Q equals 0, maybe. And let me back up here. Right, so showing how probabilities of necessity are bounded as a function of excess risk ratio and the confounding factor. And B is showing how, this is just when you assume monotonicity. Then probability necessity is just equal to a single value. Then back to the paper. Talking about figure 2 in the paper?
Yeah.
Yeah, okay.
Yeah, what's going on here?
Okay, so let's talk about P2. First of all, P2 was incorrectly defined in the paper, or it was defined twice, right? But only one of them actually makes sense. So let's go back to P2 first. So P2 says, here, hold on, let me find it. P2, there we go. So patients not carrying the syndrome, on the other hand, so this is Z equals 0, incur death with probability P2 if they take the drug, and with probability P2 if they don't take. So obviously that's a mistake. So then which one is the correct one? So he says, we further assume that P2 is greater than P1 so that the drug appears to be a risk factor for ordinary patients. So that means that if they take, that P2 is the probability that if they take the drug that they'll die. And so if that number is larger than the probability that they'll die if they don't take the drug, then that means that this must be P1. So just going back to so P2 is the probability of death given not taking the drug and not having the syndrome. That's what P2 corresponds to, okay? Not taking the drug or taking the drug and dying. Did I go through that too quickly? Do you want me to say that one more time, or does that make sense?
Makes sense to me.
Okay, cool. So then, where are we? Okay, so here we are. So now P2 is the probability of death given that you don't have the syndrome and you do take the drug, right? And so if the probability is 1, that's the worst case scenario. And then it goes all the way down to the probability of dying given that you take the drug is 0.25.
Oh,
right?
I see. Okay, so in the case where P2 equals 1, the lower bound and the upper bound are the same.
Yes.
Okay, so that red curve is always the lower bound. Is that?
Yes, that's right.
And as P2 drifts down, the bound becomes looser and looser.
Yes.
Okay. And what is there an interpretation to beta here?
Beta is, okay, probability of necessity, and this is Q2 over Q1 times P2. So let's go back to what Q2 is. So Q2 in here, so Q2 is this guy right there, which is the probability of taking the drug given the syndrome. So if you have the syndrome, the way that they set it up is that you're extremely unlikely to take the drug. You're like, the drug gives you really bad side effects, and so you just never take it, right? And so that's the probability of your syndrome, which is always going to die. So if you have the syndrome, you're dead, right? And so the question is, how likely is it that you took the drug given that you have the syndrome? So that's the Q2 part. Here. And then you divide that by the probability of Q1 and P2. So what's Q1? Q1 is probability of not taking the drug, not having the syndrome, and probability of dying even though you didn't take the drug and you don't have the syndrome, right? So just randomly dying, I guess, and not because you have the syndrome. And then P1 is the probability of taking the drug given that you don't have the syndrome. So if I took the probability of taking the drug, not having the syndrome, and the probability of not taking the drug, and of death given not taking the drug and no syndrome, and that's the denominator, and this is the so I'm not giving you a great intuition here. What is that? I think he actually defines beta, right, somewhere. But yeah, so here's Q1 and Q2, and so he says Q2 divided by Q1
beta is
times
just sort of,
Q1.
it's just,
What was that?
It's just sort of the thing that controls the gap, basically.
Well, it's half of the things that control the gap, because the other half is the probability of necessity, right? Because the probability changes as beta changes. Because Pn is also a function of these probabilities as well. So I guess that's what's going on, is that, yes, as you change beta, then the probability of necessity changes at the same time, but you still end up with these different gaps. Or I guess for different values of beta, that will change the different values of probability of necessity. And if you specifically change a P2, then you get this kind of contour.
Yeah. And every time I read one of these articles or book chapters by Pearl that presents bounds like this, I find them totally
Like,
impenetrable.
how did he come up with it? I guess the question.
Well, I mean, I suspect that as as always, that the bound, at least the lower bound, just pops out from including the latent variable in your counterfactual calculations.
Okay. That makes sense, right? If you're not measuring Z, you don't know what proportion of Z is in the.
If you're not measuring Z, you have to integrate it out in your model.
Yeah.
And that means that's going to make your, the result of your query less sharp.
Yes. Yes. That makes, yeah.
The upper bounds are a little bit harder to understand. But, you know, probably there's some similar logic.
Yeah, he proves, I guess, in causality, he proves these bounds. So let's see. Oh, actually, yeah, go back to here. He talks about where he proves it in this paper, in here. He says, oh, it's been shown that the expression provides a lower bound, and they're given by this, right? So it just says Tian and Pearl 2000. So maybe that's in causality, or maybe it's not. Unclear.
Yeah, I suspect the lower bounds are just I mean, the lower bounds I think usually make sense. Just imagining, you know, integrating out z. The upper bound. I don't know. It's always hard to kind of disentangle. There's a bunch of specific structure, especially monotonicity and the binary structure that it pops out in these.
Wait.
In these bounds, like the fact that all the variables are binary. Well, I guess there's no monotonicity of the bounds, but anyway, the fact that all the variables are binary kind of clutters up the abstract probabilistic notion in the bound.
You were Robert, when you were going through your paper, you were looking in causality. You remember what section it was that you found? We talked about the bounds, natural bounds.
7 or 8, maybe.
Well, that's what I was trying to remember.
Well, yeah. Again, I don't think Pearl's presentation of the bounds in either the book or any of the papers that he's written are very good. I find them impossible to understand.
All right, I'm gonna let this go.
I mean, so you're saying that just the derivation of the bounds is a bit opaque, or the explanation of the said derivation?
Yeah, well, they're both they're sort of opaque. I guess I have a few problems with them. One, they're sort of opaque and presented as a sort of a fait, a complete. And they're also I think that they're decoupled from the actual structural causal model, and then they aren't a series of kind of, and often the bounds kind of are this mishmash of different levels of abstraction where they always include some specific details of the toy structural causal model that Pearl's using in his example.
Do they? That's not what I remember from the book. I have the book. I didn't bring it.
This one does, right? I mean, for example, the fact that there are only these two variables, and the variables are both binary, and
so here he's defining probable necessity, sufficiency, and necessity and sufficiency, and now he talks about bounds on conditions of identification. So he actually just has some kind of linear programming formulation. And he optimizes.
What chapter are you in?
This is not a chapter. This is the reference where he said this is Tian and Pearl 2000.
I think this is in chapter 8 of his book.
Yeah.
Oh, okay. So back to causality, chapter 8.
I don't know, the bounds are really, I thought they were kind of presented okay. I mean, because if you had the full structural model, you'd be done, right? You wouldn't need to think about bounds or anything like that. You would just do abduction action in prediction and you'd be done. So the issue here is like, okay, well, we can still get at this.
Well, the point is that you don't observe some of those variables. They're there. You just don't observe them, right? Z is there. That's the whole point of this entire example.
You don't observe some of them, but I also think
the entire court case example is that Z is is that this latent confounder Z is screwing up here.
So you have some, so there's the issue of latency. And so like that there's one, so we talked about monotonicity. There's another condition called, what does he call it? It's monotonicity, and then, well, it basically, I can't remember what it's called. It'll there if it pops up, Jeremy, but it's basically the idea that you, if you're there's no confounding, that you're adjusting for confounders in the conditioning part of your counterfactual statement, exogeneity.
Mm-hmm.
And
yeah, again, that's not true in this court case example. In this the example in the paper.
Yeah, we have a hidden variable called.
There is a latent confounder, and the fact that we can do anything at all is because we make this monotonicity assumption, or the fact that we get an identification result is that we assume monotonicity, and then we can get bounds by dropping that assumption, right, and assuming this particular structural causal model.
Right. So you don't have exogeneity. Then the question is, okay, so what can you do? And if you have monotonicity, you can get some kind of bounds, which
no, the bound, you don't need bounds for if you assume monotonicity. They start assuming monotonicity and they get a number and they say, okay, now let's see what happens if we do introduce if we don't assume monotonicity. And they show that just because of the construction of the problem, you still get probability of 1. So it's a very contrived example, but it proves their point, right?
I think so. Anyway, I think what I was going to say was the logic itself, I think, is useful in the sense that with some latent variables and without knowing the structural causal model, if certain assumptions hold true, then I can get some identifiability of these queries from observational or interventional data. And I always thought that would be this. In fact, this kind of stuff was exactly what I started thinking of when I started reading on Sam's work on Gaussian processes and causality, because I was thinking, oh, okay, then say somebody could put like you could use this approach to put a prior on models that all satisfy these set of assumptions, and therefore you could have a kind of equivalence class of generative models that are guaranteed to give you identifiable counterfactuals, and you could base those assumptions based on domain knowledge. In fact, I always wondered, I wonder why Sam never wrote that up, because Sam's busy, and evidently he's uneasy with what Pearl's doing here. So I guess that paper will never get written.
It'd always be you, Robert. It could always be.
Yeah, I'll just give me 5 more hours in each day.
One other thought. No, go ahead.
Go ahead, then. I'm sorry. I've been talking enough.
Well, I had a thought separate to the bounds question. I think we can look into that later. This thing you brought up earlier about his last section, probability 1 scenarios. I found myself like both in agreement and disagreement. Like I agreed with most of his points, but then I still kind of disagree in the sense that I think most statements of probability 1 are like false in some fundamental sense, right? Like, I mean, they're true relative to your model, but your model is not true. So that's how I come to this question of, can we have any statements? Like, it doesn't make sense to ever really say that something is truly certain. Like for me, only relative to a particular model and not relative to the world, right?
I mean, we can do that. Don't we deal with that with statistics? Can't we, use, I don't know, a Kaike information criterion or widely applicable information criterion, something to kind of quantify the distance between the ground truth model and the model that we're using. I'm not saying that it's not easy, but we have ways of thinking about that.
I guess my point is that often the ground truth model is like the universe, the real universe, right? So there's always some, a model is a model by virtue of the fact that it doesn't capture the whole universe. And so I guess all I'm saying is that I think there are very few things that we can say with certainty, but it's not for the reasons that he's written down in his piece. Yeah.
So that looks like a natural law in the conversation. Should we call it for today? Do we have an idea what we want to read next time?
Do you have any suggestions, Anna? One possibility is to look at chapter 10 of Pearl's book on his notion of actual causality.
Is it? I didn't even know it was in this book. Which book?
We call
The
it
second edition of causality.
Yeah.
Yep.
Sure.
Alternatively, you could suggest a primary source.
There's also there's that Mackey paper, which is actually, he talks about Mackey's work inside on page in chapter 10. So we could read one, and then because I know because you're the one who put me on Mackey recently, Zana, and so we could read one or the other in either order. Useful.
Yeah. So if we want to do a brief tour on actual causality, then we could. Do you know if I'm actually not sure of the order of which things are published. So does the book have all three versions of actual causality? Do you know?
Whose book? Joseph Halpern's?
No, Pearl's book.
Pearl's book.
That I doubt. I think he probably has a definition of actual causality. I haven't read that chapter, to be honest, so I don't know.
Here's the table of contents there.
I think the most recent revision is 2009, right?
Yeah.
So Zena, when did the Pearl Halpern operation happen?
I think after.
No, way before. Structural causal models were developed by Halpern, right?
Wasn't Halpern's book more recent than Pearl's?
Yes, Halpern's book is more recent. That's true.
Yeah, I mean, at any rate, there's only one definition of Pearl only gives one definition of actual causality in this chapter.
But which one?
There's a bunch of technical gadgetry about causal beams and 10.3, 10.3.1.
An
event X is an actual cause of an event Y if there exists a natural causal beam.
I haven't read that. I haven't read anything about beams before.
What is this? We haven't read about this INUS condition with Mackey, right?
Yeah. This is the sort of the classical philosophical notion. It's there at the paragraph at the bottom of your screen. So the INUS condition states that, scroll up. Yeah, the INUS condition states that, so on and so forth.
And it's sufficient but necessary part of a condition, which is itself unnecessary but sufficient for the result.
The thrust of this chapter is that
big of a tongue
that's
twister.
the right way of thinking about it, and just nobody has up to that point formalized it correctly.
Yeah, so I don't know which version of Pearl's definition he goes into here, but he basically, him and Halpern have three. And then there's this INUS condition, and then there's this paper which I told Robert about, which is by a philosopher called Strevens, who basically takes this INUS condition and spins it in a different light to kind of handle some of the shortcomings. But this is a philosophy paper. I mean, I find it really interesting. It's not a mathematical paper. But it'd be good. I think we could start either on this chapter or on just the papers themselves. I just don't know which one is more.
I think the chapter is pretty self-contained.
Okay.
It's got a bunch of background. I mean, it's as you say, it's Pearl shaking his fist. So there's a bunch of fist shaking literature review.
Yeah, and and then if we after this we do read some. I mean, the paper we just read was for a legal audience. I don't mind reading papers of a more philosophical or cognitive science bent.
It's funny because Let me find the tweet. Somebody tweeted, somebody I know, this guy, John Hopkins, tweeted about actual causality, and he tagged me. He wanted some references, and so I posted back this paper, the Halpin paper, and also the INUS paper, and also Shevens's kind of remix. And then Uday Pearl jumps in. He's like, something like, I don't know, something very dismissive. Let me try and find.
All right, now I'm curious. Can you share your screen?
I gotta find the tweet first.
I had my Pearl chastising me coming of age a few months ago. So,
oh, really?
Yeah.
Yeah.
It's a minor thing, but no worries. Maybe a necessary condition for getting a PhD in this field. So.
Yeah, well, no one is spared, right? I mean, he has all these, spent years and years writing snarky comments on Andrew Gellman's blog before Twitter was a thing.
Right.
Still is, right?
Yeah.
I thought the discourse around Alex Damore's, and Co's big like Google paper.
The probability tree, yeah. Or
No,
which
not
one?
the probability tree.
Yeah.
The paper that he wrote about
Right.
under specification.
Underspecified.
Under specification, yeah. The idea was like training just to
essentially
optimize a loss function is insufficient to kind of generalize, right? Yeah.
Right. He's like yelling to the world, like, "Hey, identifiability matters," right? And then Pearl yells at him and says, "No, we should be thinking about this as identifiability." And it's like, oh,
yeah,
this guy's advertising your work, like.
So actually, John Urbanik chastised Judah Pearl because he's like, you're shooting them, you're shooting the wrong messenger, basically.
Right.
And then he actually backed down after John Urbanik said that.
Wait, what was the argument? I'm missing something.
I'll pull that up. Let's see.
I think it's a question of marketing. So if Alex Damore wrote this, I guess I wouldn't say he wrote it, like it's like a 30 author paper to the machine learning community saying essentially, they didn't use the words, but essentially saying you should care about identifiability because minimizing a loss function has some weird consequences if things change.
Right. And so like it's a one thing that I've learned about kind of connecting causal reasoning with machine learning is that the kind of old causal inference researcher habit of specifying like a really simple toy model as a DAG and then, and with an example that's a bit contrived and showing that, something that people often do, like, assume that the E of Y given X is equal to the E of Y given do X doesn't work. That if that's going to just roll right off their shoulders, the machine learning community shoulders, because they have some kind of, I should say, we have some kind of filter for practical hard problems, and so like you need to be able to make the argument in those terms in order to find a receptive audience, and that's all Alex was doing. I mean, like it's funny, like the word causality barely pops up in that entire paper.
That was intentional.
Yeah, it was. You can see him doing a little bit like almost doing somersaults, not to say it out loud, but or I shouldn't speak for him, but I mean that's what I felt when I was reading it. But yeah, so that was that. That was a bit weird, but I think I for one look forward to seeing more from Alex in this group. So.
Yeah.
There's a link, by the way. It's not that bad. It's just Pearl disagreeing with me, basically.
Can you just share?
Okay, one sec.
Yeah, it's like a badge of honor.
Yeah. So where is it?
He liked our paper, Jeremy, didn't he?
He did. So far, we have not crossed him.
Can you see my screen?
Yeah.
Yeah, so my friend of mine, Jovo, just asks, causal people, can you mathify the following? When I turn a light on in my house, what caused it to go on? And I just basically said, see actual causality, tag you there, Pearl, have a few papers there. Most of these mathematicians are based on counterfactuals. My hunch is that there's another way. And I give him some links, and then Pearl jumps in. So I said, I think Mackie is underappreciated, in my opinion. Pearl jumps in. I do not think Mackie is underappreciated. Same with Rothman's sufficient causes. The weaknesses and ambiguities in the approach are noted in chapter 10 of causality. And I do not see modern authors addressing them. See also.
Right. So he's saying that Mackie Remix does not really address the issue that he raised in chapter 10.
Yeah, or I guess Mackie, maybe not Mackie Remixed. I don't know.
So mine was maybe less pleasant. So I said something to the effect of like, I can't remember if structural causal models allow loops or not. And he responded saying, why wonder? It's written down so clearly. Which is, it's fine.
One thing I've never really understood is why recursive causal graphical models are like defined as like they use the term recursive for graphical models.
Yes.
Without
yeah,
loops,
I've seen that.
right?
I don't get it either.
Right. No, there's a reason. It comes from econometrics, and the idea is that you can write. If it's recursive, it means you can write. If you have a causal chain, right? Like A causes B causes C, you can write C in terms of B, but then you can rewrite it in terms of A. So you can kind of recursively redefine C only in terms of A. But if you have a non-recursive causal model, you cannot do that.
It's just very unfortunate.
I know, it's a terrible term. Because, the non-recursive is exactly what you would think would be recursive, right?
Right.
But yeah, it's about having a triangular matrix, basically, when you define your structural equation models.
It was funny when we were talking about beams, the last comment, and then we can go. It reminded me of my undergrad where, I was a mechanical engineering student and we're like solving differential equations for, how beams vibrate. And it's kind of like a, PTSD for a second. I don't think it's the same thing, thankfully.
Yeah.
I guess we'll have to find out what beams,
Well, I'm not entirely sure I understand it either. I guess it's like you take a structural causal model, fix a value for the noise variables because you're interested in a particular state of the world, and then construct a new structural causal model that contains where you drop all of the sort of the functional dependencies that become constant when you're fixed in that state of the world. Something like that.
Yeah. So, we can all just leave, but all of these issues, or most of these issues, come down to trying to fix preemption, and it has this weird kind of flavor because it seems like it shouldn't be a hard problem, but it seems very hard for some reason, right? Which to me indicates that something is just like fundamentally off about the whole approach. Like, and as we'll see, maybe I'm not sure which versions he goes through, but Halpin and Pearl, they literally had 3 papers where each paper's like, oh, actually this previous one didn't quite work. And the final version, it's kind of complicated, right? Like, and I don't know, maybe it's just like necessarily complicated. Like a large part of my opposition to it is just like how complicated it is.
Starting to feel like it's epicycles, huh?
Right. So I don't know. Anyway, we'll see you next week when you read it.
Yeah.
Do you have any worked examples where the current theory, don't match intuition or sort of what we know is true?
I don't have any no, I don't have concrete examples where I can say this doesn't match. I mean, and what you say is kind of one of the issues about this whole paradigm, which is that the metric for success is whether it matches what you think it should do, right? And maybe that's just necessarily the case, but also it seems kind of shaky. I don't know.
Well, maybe I think kind of the sort of conclusion at the end of the chapter 10 Pearl's book is that all this actual causality stuff is kind of it's sort of, there's some arbitrary, it depends on some like particular fixed notions of pragmatics, right? Precisely this, this correspondence between what we mean and the particular definitions that we choose. And he says, well, I'll talk about that some other time. Like I gave this particular definition of actual causality in terms of these bit of technical gadgetry and these weird queries. But actually, whenever we try and talk about a particular example, the details depend entirely on the extent to which we can, the extent to which and the way in which we formalize our sort of natural language counterfactual that we have in mind. So, I mean, one conclusion would just be that actual causality is not a particularly natural notion, that it's contingent on queries and models.
We should definitely, if we're going to go down that road, we should definitely look at some of that explanation literature, because that's coming at well, insofar as actual causality is kind of primary use cases for constructing explanations for what happened, then understanding how cog sci people are thinking about explanations. And because obviously if it doesn't have some kind of natural kind of intuition to it, then what are we doing? I'm curious if Zena, actually, if you have any work.
Well, I think the point is that the intuition is ambiguous, not that it imposes, it's that it doesn't impose enough. There aren't enough constraints in our intuition. And so we have to think really hard about adding enough constraints to make actual causality precise.
I mean, there are people have formalized it, but just like.
Sure, but the point is that it's not, the counterfactual statements that we make in the course of common sense reasoning or in natural language are often, when you consider those statements in isolation,
there's going to be like
they're under constrained. They're not. When we talk about actual causality in natural language, our statements are under constrained.
Yeah, and so when we actually reason with them, there's a bunch of cognitive biases that go in there, but you can model them. So, do you have any worked examples with omega
on actual causality?
Yeah.
I mean, we've got some but-for examples, but not. One of my other opposition to Pearl's approach is that it's completely intractable to compute, right? Like when you get into the actual definition, it requires this like double quantification. So I have but-for causalities examples that we could work through, but it's not that complicated. The approach that I've been taking outside of Omega, this other project, is in terms of actual causality, but it's more in terms of like understanding the dynamics of the program, right? So my basic intuition is that actual causality, the counterfactual version, works somewhat as a reflection of this underlying dynamics of the model. And so we're trying to see if we can formulate actual causality in a kind of not purely counterfactual way, but by following how your program evolves over time. But this is research, and so we don't have full answers yet. But we do have some working examples we can.
Yeah, I mean, maybe one way to resolve the ambiguity is to imagine that actual causality is a notion that relates pairs of queries, pairs of counterfactual queries, and not something we can talk about in isolation for a single query or a single model.
Right. So this paper that I said to you, Robert, this one by Tim Miller on explanations, he talks a lot about this notion that basically all notions of causation should be contrasted. Like, it doesn't make sense to say, does A cause B? You really, there's some like implicit foil. It's like, does A cause B, as opposed to, you know,
Right.
C, right?
Yeah. Or some instrumental end, like does, you know, does A cause B, such that if I, you know, does like pulling the lever open the door when the light is blue, you know, does that mean that if does pulling the lever, opening the door, mean that I can get some food, you know, no matter what color the light is or something? I don't know. It's instrumental with respect to, it's a causal notion that you know, it's a piece of causal knowledge that you want to use in a different query.
There's a paper by, I think it's Tania Lombroso. If I'm getting that wrong, I apologize. But where she argues that, well, so when it comes to, say, a cog sci perspective on explanations, people are comfortable with that duality, right? So, for example, you can ask me, why is the knife sharp? And I can answer from a mechanistic perspective, in the sense that it's sharp because it was sharpened with a whetstone. Or you can answer with a functional perspective, like it's sharp because it is meant to cut things, and people are cool with that. But in causality, we don't seem to be comfortable admitting kind of that kind of duality in terms of mechanism versus function, or say mechanism versus dependence in a DAG or something like that. And so maybe that's a problem. Maybe we should take a page from their book.
Yeah. Yeah, there's a bunch of I don't know, there's a kind of orphan branch of RL on the reinforcement learning literature on these this notion of predictive state representations, which are basically a sort of, you assemble all of your knowledge about the world in the form of a set of tests, basically, even interventional queries. Say, if I do this, then this happens, and you use that to reason about, in lieu of a model, to reason about, you know, to either to do optimal control or reinforcement learning, or, you know, to reason about other tests. That might be another interesting bit of literature to look at some point.
Yeah, there's some neat work just coming out of DeepMind, where they're using causal influence diagrams and combining that with causal models to talk about incentives for agents. I think it's kind of interesting. I just read there's a whole series of papers, but I read the most recent one this weekend.
Yeah, that stuff's a bit different. I think it's less controversial than from a philosophical perspective than the actual causality.
Fair enough.
That we're talking about, although it is certainly interesting. But anyway, so how about this? We'll Zena, why don't you like skim at some point this afternoon, like look at the definition in chapter 10 of Pearl's book, and send me something else if you think we should read something else, and I'll send that out. Otherwise, I'll assume that we're reading.
Also, Pearl,
Sounds good.
and also then in the forum we have, there's that other reading group for like philosophy of AI, or I think that's what it is. But like there's that we took that explanation reading list from that iCard had at Stanford, and we adapted it a bit. But so there might be some things in that list worth picking up as well.
Cool.
But for next week, we're doing chapter 10 in Pearl.
Yeah, unless Senna says that we should look at one of those other papers, one of the other Halpern and Pearl papers that has a better definition.
Or a Mackie, or whatever. What do you say, Zena?
I think we should start with one of the Halp and Pearl ones. If you want to read Mackie, just do it afterwards or at the same time, but it's probably a lot to do at once.
Yeah, yeah, I agree. Okay, I got to
So
run.
is that chapter 10 or is that a new paper? You mean?
Let's just do
Chapter 10 of
Yeah.
the second edition of Pearl's book.
Okay.
I'll send out the thing.
All right.
Yeah.
Thanks everybody.
Yeah.